Okay, let's try problem 2.2 here. And in this problem, we are given that we have two force vectors, F and 700 newtons. We do not know the magnitude of force F, and we do not know the angle that it acts here. But what we do know is if we add these two forces together, we want a resultant force that acts directly in the y direction, in the positive y direction, and that is supposed to be 500 newtons. Okay, so let's write down what we know here. And I'm just going to draw a quick free body diagram. All right, so we have F pointed this direction at an angle of theta, and then we have 700 newtons, which is roughly in that direction here, and that is 15 degrees. And we can call this F2 if we want, 700 newtons. And when we add these two together, what we're actually looking for is a resultant vector that is directly vertical here. And we're looking for that resultant vector, FR, is equal to 500 newtons. Okay. Let's scroll down here a bit. So, what are we looking to find here? Well, we're looking to find the magnitude of F and theta. Okay, let's do our analysis. So let's look at if we know that F plus F2, and I'm going to put hats on both of these to show that they're vectors, equals our resultant vector. We know F2 here is 700 newtons, and we know the resultant vector is 500 newtons pointed directly up. So let's rearrange this equation so we have the unknown on one side and what we know on the other side. So that comes out to be F equals FR minus F2. So remember that when we add vectors together, right, we add them tip to tail. If we want to subtract vectors, it's like adding the vector but in the opposite direction. So if we're subtracting F2 here, right, instead of drawing F2 downwards this way, we would draw it the opposite direction. So let's just draw a triangle here, adding these vectors tip to tail. So we have our resultant vector, and that is just a vertical vector here, that's FR. And negative F2, remember, is 15 degrees down and to the left. But negative F2 would be in this direction here, F2. Now let's put a negative there. Okay, and there we have F. So F is the vector from here to here. All right, that's our vector F. So if we take FR and add negative F2 to it, we get this F vector here. And we know that this angle is 15 degrees. And we know that this is a right angle, so this total internal angle here is actually 105 degrees. 105 degrees there. And the theta that we're looking for is this angle here. Okay. So if you remember from geometry, we have this thing called the law of cosines. And I'm just going to draw a quick triangle to demonstrate this property. All right, and we're going to call these lengths of the sides A, B, and C. And then we're going to call this angle in between here theta. All right, what the law of cosine says is if we know two adjacent sides and the internal angle between those, we can figure out the side length C. We know that C squared is equal to A squared plus B squared minus 2A times C cosine of theta, this angle between here. Okay, so now let's apply this to our problem, right? We know FR is equal to 500 newtons. And we know this F2, the magnitude of F2 is equal to 700 newtons. Okay. So we know these two legs here, and then the internal angle between those is 105. So we can find the magnitude of F. So the magnitude of F, I'm going to put lines here to indicate the magnitude of F squared, is nothing more than 500 squared plus 700 squared minus 2 times 500 times 700 times the cosine of 105 degrees. And make sure your calculator's in degrees here. And if we find this side and take the square root, right, we need to take the square root because there's a square on this side, we find the magnitude of F is equal to 960 newtons. Okay, that's one thing that we need to, well, not degrees, newtons. So 960 newtons. Okay, so we've solved this part of the problem, and now we need to solve for theta. Well, theta is this angle here, all right? We have another geometric property, which is called the law of sines. And I'm just going to draw another triangle. All right, we can call this A, B, and C again. And the angle here we're going to call alpha. And the angle here we're going to call beta. And the angle here we'll call gamma. Okay. What the law of sine says is the sine of alpha divided by the length of A is equal to the sine of beta divided by B, which is then equal to the sine of gamma over C. Okay, and notice how I arranged these, right? It is the angle, it's the way this is, the proportions work, it's the angle here in the opposite side length. So make sure that you have the triangle arranged in the proper way here. All right, so alpha corresponds with A, beta corresponds with B, and gamma corresponds with C. All right, well, we can use this law of sines in our own problem here. And we know what this angle is, and we know what F is, so we can use that. We know that this is 700 newtons up here, and we can use that to find this angle here, which I'm just going to call theta 2. The angle that we're looking for is theta, but theta 2 and theta add up to 90 degrees. Okay, so let's do that. So we have the sine of 105 degrees divided by the opposite side, so 105 here, and we have F, which we just found, which is 960, is equal to the sine of theta 2 divided by the length opposite of theta 2, which is 700. All right, so we can move the 700 to this side and take the inverse sign. We come out where theta 2 is equal to 44.8 degrees, right? That's not exactly what we want because we're looking for theta here, not theta 2, but we know theta plus theta 2 is equal to 90 degrees. So we can sub in theta 2 here, and we can figure out theta. So then theta comes out to be 45.2 degrees. So there are our answers for this problem, and that's it.